Oh no, class is not over. What? How's everyone doing? Good afternoon. Good to see you here. We can work on some questions. We've already got a lot done today. If you're in the chat, feel free to say hi. We'll throw out some points right here. Mubot, are you awake? He might not be. The answer is he's Mubot awake. He says nope, he can't send messages. If you're in the chat, jump in with your questions. I saw we had one like on. Hey, Dylan, great to see you here. Do you have the code, Dylan, or do you just want to start doing the reactive buttons? Let's go take a look at that. I see you messaged. Oh, potatoes and onions, zucchini and okra. Oh, grow right. Next week, poblano. You're making some poblanos? What? I wish we were doing gardening. I don't have the area to do gardening. I wish we were making some poblanos. But you've got zucchini and okra and potatoes and garlic or onions. I don't see some garlic on there, but I do love some garlic. So we can try to make this reactive button. So what we need to do is I need to grab the latest working version of the app. I think it's a little bit further back right here. Which one was the working version? Let me grab. We're just going to take the timer from it. You got the final edits. Let's go right here. Final countdown app. I think this one right here is this. Okay, I think this is the right version. So let's go check this out right here. Okay, let's go take a look over there on stream. So, hey, Alexa, great to see you here. The gas mileage, you bet. We're going to do a little bit of shiny, and then we're going to see if we can get this going. Let's see how quick. Dylan, let's try to speed run this right here. And then Alexa, we can definitely, thank you so much. We're going to do a little time series shiny buttons. And then Alexa, we have chapter 4 quiz, stat 201, chapter 4 quiz, and gas mileage. I think that's a back-to-back stem and leaf. So Alexa, you got it. We'll put that in the video right here. We're going to try to do this shiny button thing right here. And you're welcome. Thank you so much for being here. Let's go take a look. Dylan, first question of the day. That's at 2:43. And here we go. First question of the afternoon, rather. And so with this right here, we have Dylan's app that he created. We'll just take a quick look at it again. Dylan and I contributed to this. I did a little bit of work. How many clicks can you get in 5 seconds? Does it still play our song? Gotta watch out. Oh, it does the song, but then it crashes. We might even crash R with this. So dismiss. Let's try it again. We haven't been copyright. Oh, wrong button. Played a little bit more song than we wanted to right there. So this just counts your clicks as you click away on this right here. We've gotten like 54, I think is our high score. And then I got 10-3, just not really trying right there. Okay, we got to give it a real try. We've crashed R doing this, though. Oh, I was off of it. That was bad. That was bad. Not good, not good. Well, okay. We've gotten 54. Check out other videos if you don't believe me. So we need to grab this timer right here. The timer is the key component for what Dylan's trying to do. Dylan wants a reactive button that appears. So we'll do a little work on this. The timer, which we've already created, so we're just going to take our code right here to create the timer. The timer, here it is right here. This is the current time being created. We don't really need to worry about the paste, but that's the render text. And we are taking the, here we go, the timer. Okay. And where are we creating that again? It's timer right there. Here it is. Reactive value 4. That's where it's just setting it to a certain time. And then this is where the timer starts. So here's the thing, Dylan. This is where, that's the clicks. This is the timer going down. So if active. So we are observing right here the session, and that's when it equals 0. Oh, where's the timer being created again? Darn it. That's where it's observing that. It's not right there. Server event input timer, reactive value number clicks 0. Up higher. What lines is it, Dylan? Is it right here? That's not going to create, that's going to just create a reactive value. Oh, and then we're counting down. So that sets the time for it right there. But we're not starting the timer on that right there. Like, I think we can create an app that just has the timer, which we originally did. So let's go grab that code that makes a timer in R, because it's the invalidate stuff, which I've only used a little bit and it's easier. It's this starts it. So that sets the value right there. And then the right here invalidate, I think this is how many seconds. So this right here starts it. And if we put this on this, so this is doing the if active. We got the Easter egg right there. I kind of used your code for the backbone of that. So what you probably want to do, here's the render UI. Because we might even be able to like use our code right here. So if this is just a true thing right here, so this is set to true. So I wonder if what we could do is, I just set that to always true. I just like 2 equals 2 stuff. If we go to the main panel, can we just add in a button? Because this is set to true right here, so it'll start doing the color thing. So the question then becomes, we're inside of main panel right now, right, Dylan? So this is updating the UI with the main panel. So it's going up here, and the main panel is this inside of it. But those are just all the options. Here's the second main panel. Why do we have 2 main panels? Didn't know that would work. That's interesting. So I could possibly change the... Yeah, try that. Try changing the arguments right there. I'm just wondering if we could take this action button right here and grab it. There's like 5 main panels. What have we done? So let's go here to this and update with a new action button. And this right here, and let's put input ID clicks to, and say it works. Okay. If this works, then this way of doing it works. And the answer is, it doesn't. It's not updating the UI like I thought it would. We're still muted on the music. That's good. Actually, so I think it can update the UI. I think you could update the clicks. Can it update the clicks? No, it's not doing that. I would think it would have updated main panel, blah, 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 blah. I would thought it would update action button. Update an action, or, oh my gosh. Have an action button appear in the UI. Okay. Have an action button appear in Shiny UI. Make a new action button appear if previous inputs is not empty, disappear if. So this person on Stack Overflow is doing something a little bit similar. I'm still inside. I'm still inside set background color. Oh, gotta watch my parentheses. Oh, Dylan. Wow. There's the main panel. What? Will that update the action button? Find out. Okay. Oh my gosh. Wait. Oh, we broke our. I saw the it works button. Maybe, I don't know why it would crash. But Dylan, look. Oh, I think I know why. Because we have it assigned to, that could be why it crashed right there. I've got this called, so literally I think we just solved it. Too many things called clicks. But I think, yeah, it definitely was there. I saw it for that half second. Clicks 2. I think it's because I used the same input ID, so it got mad. You gotta hear Journey for a second. It's Journey, right? Oh my gosh! There you go. Dylan, it worked. There you go. Does that make sense? So it is under the update UI. So we now have a button that appears by going to the, it's render UI. So the render UI is going to then allow us to kind of, it's not an update UI, it's a render UI. So it is under this. We are able to add that additional thing right there. And we have it set to go when the button is clicked. So it's looking at the timer being active. So clicking the button right there starts the active timer. So once basically the active timer is started, we do get this new button appearing right here. So Dylan, that's got it. How's that looking? That's what you're Oh, we just played the full song. Please don't. I got to be careful on that. Please don't copyright claim us. Please don't. Thank you. They can see the parts of the video. Shout outs to Journey right there. Makes perfect sense. Yeah, well, thank you, Dylan. Great questions right there. Let's hope the video, if office hours have ads on them, it's because we got copyright claimed and we got bots in the chat. Hide those bots on the channel. Let's go over to the main screen. Really great stuff right there. Really great practice. And Dylan, 100 points. I'm not hearing the music. Oh my gosh. I've got my audio turned off from the computer. So you didn't even hear it. We don't got to worry about those copyright claims. And so now you could hear it if I played it. Watch, you'll hear it now. There we go. But now I only played seconds of it. You're good for DMCA. You're right. I had the audio turned off on the computer. I wonder, I didn't play anything else during class, did I? I don't know. Turned off the audio on the computer, routing through. I could hear it, but you could not. So let's go ahead and check out the next question. So we're about to do some chapter 4 for Stat 201. Let's take a look at that right here. A little bit of music. Oh no. I wonder if they're turned off for office hours. There we go. Let's go to chapter 4, 201. The gas prices we're going to look at. Dylan, these are great questions. Really good practice. And you caught a little thing right there. I was like, theoretically, what I was doing should work. You're great. Yeah, go play in the dirt. Like when you're like, theoretically, this should work. And then you just put it in the wrong parentheses. So you caught it. I was in the set background color. So, Dylan, you caught an error that I was making in code because I'll make a few errors here and there. My Pearson's being weird right now. My Pearson, don't be weird. We're getting my Pearson loaded up. So I think it was Alexa. We'll have my Pearson working here in a second. Or not. Who knows? Maybe we're crashing. I'm going to reload my Pearson here in the background while we're doing this. Okay, it's loading in. We're going to find that gas price problem and let me know if you have more problems on here that we want to do. So the gas price problem, where is it at? Okay, it was crashing last time. Gas prices of like foreign nations. Oh, I think we found it. Yep, gas mileage. Let me take the timestamp and let's get started on the gas prices. Join in if you're still here. Start working on this. We speed ran that last thing. Here we go. Gas prices of foreign nations. Let's do this. So we got different countries and their gas prices here. It's important to know what kind of display we're looking at. While the graphic's not on the screen, it is going to be side-by-side or back-to-back mosaics. Oh my gosh, I can't speak today. It's going to be side-by-side or back-to-back stem and leaves. Side-by-side and back-to-back stem and leaves are in this area where we have a categorical X, like what country was it in, and then quantitative up there for the Y, which is how much was the gas prices. So you have a bivariate display currently on the screen. Now, the easiest thing to know to do with these values is to just round them. So when you're looking at a value right here, such as like 36.9, just round it to 37 and watch for the computer to zoom in too much. So 37 is what this would round to right here. 33.7 would round to 34. 32.8 would round to 29. Think about the rounded value of these. Don't worry about what it would go to. Just worry about, because it does this interesting thing, it should just say round it. But it's trying to tell you that this right here would be 27, which would represent this number right here. Kind of confusing because it's talking about then there could be something in region B, which would be this number over here. This really isn't a number. It's kind of a leading number before it, like the 2. The observations are the points right here where you see like 6, 4, 0, 1, 4. So we want to kind of differentiate between these graphics to understand, well, if you notice in region A, there is a 7 here, and that would represent something that rounds to what value? We'll give it a second right here. That 37 would represent something that rounds to what in region A? So take a moment, see if you can answer the question. This value right here, that 7, which has the leading digit 3, would represent something in region A, which all the graphics have it. So we need to see something in region A that rounds to what? I almost said it. And the big thing is to know what you're seeing right here. You're like, oh, that's a value in region A that would round to this. So it's got the leading digit 3 and the second digit 7. So it's in region A. You can see it in all the graphics, so it must exist. Well, that is the answer. Alexa, great answer right there, 100 points. That is the value. And what does 36.9 round to? It rounds to 37. So does that make sense how it's trying to tell you there is a value here, which is this value, which rounds to 37. So how about this? There's something in region A that rounds to what? So tell me what that would round to. There's something in region A that rounds to what value? There's something in region A that rounds to what value? Just round it. Round that number right there. And then let's see. And great job, Alexa, right there. There's something in region A that rounds to this. Like round this value. And then we'll look down here for it. Because there's actually two of them. Well, the first one would be 37. And then the next one would be 34. Does that make sense? Do you see 34 in any of these graphics? I'll disappear. Great job, Alexa. Which of these graphics, A, B, C, or D, has the observation of 34 in it? Now, there's multiple observations in the 30s or the low 30s, because these are the upper 30s, these are the lower 30s. And for region A, which one of these has answers in the, that say 34? And there's two of them. There's a 34, and that would round to 34 also. So which of these has the observations for the two 34s in region A? Which of these has possible answers, which we could narrow it down to be like, it could be, it's not that one. It could be, which ones could it be? So do you see which ones could it be? You got it. So we've narrowed it down now. It has to be one of those two. So really, we've narrowed it down. It has to be this region A or this region A right here, which those are identical. So let's look at region B a little bit. There's a lot of values in this region B right here in the upper whats. Like this would be something around to 36, 36, 38, 38, 39. There's a lot of values in this region B that is in the upper whats right here. Like you would say this is the lower 30s. And over here, we see a lot of high 30 values, right? Does that make sense, Alexa, right there? Like we have 36, 36, 38, 38, 39. I see 34, I see 16, 18, 20, that rounds to 20, 19. That's a 36, or that's a 36. So do you think it's B or D? Like, do you think there's a bunch of, which one do you see between B and D? Because either there's a whole bunch of upper 30 values, or there's only a 36 up here, and there's not a bunch of higher 30 values. Which one do you think it is now? Because we know it's between B and D from looking at region A. I would say it's D. Yep. It's region D because we don't have a bunch of those upper 30s. We just have that one value that rounds to 36. So you can see differences. A slight bimodality here, but a modal peak in this area. Strong unimodal shape right here with just the one peak and a little bit of outliers here on the top side. So which of the following comparisons is correct? The models in country... Computer's been a bit weird. Don't be weird, computer. Which of the following comparisons is correct? The models in country A, no, they have higher. Since they're 15, that doesn't sound right. The models for country A have higher gas than models for... Yeah, I think that's it. Good stuff. Does that make sense right there, Alexa? Just comparisons. Do you have another one? We are open on questions. So if you're working another problem, I might just do some of the multiple choice right here. But does that make more sense to track those values here in the stem and leaf and then to see the key differences right here where A has a higher kind of modal area, it's on the higher side, where B is towards the lower side? You're welcome. If you have another question, let me know. We'll hop back to the main screen. I might just do some multiple choice, but it's your guys' office hours. So if you're like, hey, 320 this, 475 this, 201 this, just be like, hey, can you explain how to do this question? Can you talk through it? Let's just do it. We'll let one song play right here. We don't play this one nearly enough. I'll click all the buttons. All the buttons. We'll give it just a moment right here and see what questions people have. Go to the Discord. Such a great way to communicate on the Discord. Let's take a look. Also, I guess I'm blinking the power, I think. Also, another question about chapter 4, the boys and the girls question. Yeah, specifically part D. Ooh, that's a tricky one. Let's go look at the boys and girls question. Oh, we're loading in. That shows you the quantiles, right? I think. Let's go take a look at the boys and girls question. Oh. Ooh. Where is it? I'm currently loading through the different things right here. So many. Up. Found it. Let's go to. That's a fun one next. We maybe do that one. Let's go check it out, Alexa. Thank you so much. Let's see right here. 2120 Stat 201 Chapter 4 quiz. Boys and girls. Okay. Let's do it. So in this question, we are given the 5-number summary. Now, if you're given something like the 5-number summary, I would immediately go in and start thinking about what do these numbers mean. In the 5-number summary, we are given the Q1, or excuse me, I should start with the lowest value. We are given the minimum value. We are given the Q1. We are given the median, the Q3, and the max. So min, Q1, median, and max. So there are the data points right there. The highest, this is a score, is it? The highest score for the boys was 5.9. Highest score for the girls was 5.6. Girls had a higher minimum though, and we can do different things. So which group had the highest score? And it looks like to me the boys had the highest score, and the boys had a high score of 5.9. So which one had the highest score? Which group had the greatest range? The range is the distance between the max and the min. So whenever we're doing range right here, we need to make sure we understand the concept is max to min. So we're just doing this distance right here. That's the range. So boys is going to be 3.6 and girls is going to be 3.1. So the boys had a greater, oh no, girls is 2.9. Just double check your math. And yeah, the boys are a greater range. Boys have a range of 3.6. Boys have a range of 3.6. Which group had the largest interquartile range? I think people sometimes make interquartile range sound harder than it is because it sounds like a complex topic, but it's just the range of the middle 50%. So the interquartile range would be this right here. It's the distance the Q1 is away from the Q3. It's a positive number, so you can just look at it mathematically. Would this be boys or girls, Alexa? Did the boys or the girls have a greater interquartile range? And can we find the value of that? So all you do is subtract the numbers right here. The boys' IQR would be this. It would be the big number minus the small number. Is that the biggest one? Is there a bigger IQR to be found? What would be the larger of the two IQRs when you just find the distance those numbers are away? Remember, it's just a range. It's just how far away are those two numbers. So don't overcomplicate it. It's just Q3 minus Q1, big number minus small number. Girls, 4.3, you're right. Girls have 5.2 minus 3.9 and 1.3. So the girls have a larger IQR right there. Which group generally did better? Okay, so these are let's see what they're saying. Ooh, the final question is the interesting one. The girls did better because the mean, no, we're not looking at means. We don't even know what the mean is right here. We got medians. So mean is not displayed in the 5-number summary. We can't, anything that says mean right now. We're not looking at the mean right now. The girls generally did better. That's the median right there. I wish I told you what those were. That's what they are. Take notes. That's 5-number summary. So the girls generally did better. Let's see. The girls did better on the reading test because the median for girls was higher than the median for boys. The girls did better on the reading test because the upper quartile for the girls was higher than the upper. No, we'd compare medians. If you say someone generally did better, you would say what's the median score on this test. So in general. Now the final question right here, you can kind of get lucky on and do it the wrong way and get it right by accident. The final question is probably the tough one that a lot of people get wrong. Because what a lot of people do is they just average these numbers and they answer 4.5. Now stop. I wish I could say stop and get everyone's attention. That's not the answer. Maybe I don't know. We'll find out. The reason this isn't the answer is because there were 12 boys and 10 girls. So we have to remember when looking at this, we need to take the average for the 12 boys. And let's go right here. There are 12 boys and 10 girls. Let's go over to Word right here and look at this. Mario. So 12 boys and 10 girls. the 12 boys had an average of this, and the 10 girls had an average of this. I think it's going to be 4.4 when it's rounded. So what this means is, if you think about the boys, would have 12 times 4.3 points. That's the kind of total points the boys got, because you could divide that amount by 12 to get the average for the boys. We would then need to add to this, the girls got 10 times 4.7. This is going to then find how many points total there were, and can you tell me what number we need to divide by? So now we need to divide by the total amount of people. So there were 12 boys, had an average of 4.3, so we can find out how many points they got. There were 10 girls that had an average of 4.7, we found out how many points they got. We're going to add these up and divide by how many observations. So the question is, how many observations total are there? So how many observations total are there? So we'll divide by what number? So just 22. You got it. Great job, Alexa. Excellent work. 22 points. Or 20, more than 22 points. 100 points right there. So there were 22 total observations. This is kind of what a weighted mean is, because we're weighting it by how many observations there are for each group. And so that the other one's going to be 47, because 10 times 4.7. Move decimal. And the answer is, we got lucky. This is one of the rare instances where you get it right and your friend doesn't. You're like, why did I get it right and they didn't? Or someone gets it wrong. They're like, why did I get it wrong? This will round to 4.5. There are instances where you don't get the free, like you could do it the wrong way and still get it right. I almost wish it never let you get it right. Like it did versions that don't allow you to average it. But down to one decimal place, that should be the answer. And we did get 100% correct. Just to show different versions right here, there are ones where you can't round it, like this one right here. So in this one right here, just to kind of do the same mathematics, there's 15 boys and 13 girls. The boys right here, 15 boys with an average of 4.7. Copy that. There were 13 girls that had an average of 5. What am I doing? Oh, yeah, there's the average 5.0. And then we add those two numbers, divide by 28, and that's how we'd get it right there. So that's 4.8. Does that make sense, Alexa, right there? That last one, you can get it right by getting lucky and just averaging the two numbers. But since it's a weighted average, it's going to pull in the direction of the larger groups. Since there's more boys right here, you can't just go 4.85 because you can't average the two numbers because there's more boys. So you have to go and do the mathematics we just did, where you take a weighted average. Yeah, that's the tough part of this problem, is you have to go back in here and solve for the amount of boys. And we'll color code this real quick. You would take the amount, and this is the 2 added up right here. So that's the 2 amounts added up. And then you would times these by the respective means of each group. So that's the means times the amount for each group times the sum of the groups. Like 10 and 12 make 22. So little tough question at the end right there. Oftentimes catches people. And then some people get it right because, like the first version we saw, I didn't actually have to do this. I could have just did it the wrong way and got it right, which is, hey, you get lucky sometimes. Any more, Alexa, whatever questions you're wondering about, let me know. Let's jump back into it. Alexa, excellent work. Thank you so much. Great work on that question. Great answers. I really like it when people are here. Let me throw you another 100 points. Chat disconnected. Successful. What is going on? I wonder if Mubot's still there. It just said my chat disconnected. Did Mubot go away? He doesn't look to be here anymore. Oh, he's there. I don't know. The craziness of the world. Did Mubot come in here and destroy the world on us? See what the questions are. Let's do some true or do some multiple choice in this. We work backwards towards the end right here. Where is the multiple choice? Oh, I'm showing all the completed. I have one more question, of course. I think the center of a box plot is a box that shows the middle half of the data. Yeah, let me find that one. Thank you for asking these, Alexa. We should find this question. All right, cool. Found it. Hey, Brianna, great to see you here. 100 points, Brianna. Let me go do multiple choice. Abe, about to take a calc exam. Oh, no. Good luck on your calc exam. 100 points. You get 100 points in the chat. Can't promise those hundreds on those calc exams. That's tough. Stat 201, Chapter 4, multiple choice. Multiple choice. Let's go check it out. Here we go. Which of the following... Oh, now it's working properly. Which of the following statements are true about box plots? Okay, well, let's take a look. What we need to get is a box plot to take a look at. Yeah, let's get a box plot. Here we go. Here's some data. And let's go here to graph builder, like your visualization assignments. Take the data, drop it right here, and click the box plot button. Check out office hours earlier today. We don't have an outlier. Let me change that. 15. Cool. Analyze. No, graph builder, like your thing. We want an outlier so we can see an outlier. And there's an outlier. Cool. Let's put the 5-number summary on here and let's take a look. Let's see if these things apply. Okay, so we're going to put so we can see both graphics on the screen at the same time. Okay. Now we have a visualization of a box plot to see if what we're seeing here makes sense. The values which are displayed as a dot or an asterisk are outliers. What do you think here? True or false for this first one? I think you're on the right track, Alexa. Are those values that are dots or asterisks outliers? Now, do remember these things should be included when talking about the range. The range of this data is 14. What do you think right here? True or false? Just T or F in the chat. Data points which are dots or asterisks. True. That is very true. So we'll go ahead and click that. Maybe we'll click the rest. The center of a box plot is a box that shows the middle half of the data. So this right here, which goes from 2 to 4.25, that is the middle. Actually, I'll disappear so you can see even better. That is the middle 50% of the data. So that box, that literal box right there, is the middle 50% of the data. So I put it right there. That box is the literal middle 50% from here to here. From, what's rounding it? I don't like that. It does that. So 4.25 is exactly where that's at. That's the middle 50%. That is true. Box plots are a great way to compare multiple groups. Sure, let's take a look at that. Let's go here to graph builder. We need to go to a different data set. Could we compare multiple groups with box plots? So let's go here to graph builder. Let's compare distance from campus. Let's compare high school GPA. And there we go. Multiple groups being compared right there. So most definitely, yes, side-by-side box plots. Do remember it is saying plural right here. Box plots, not a singular. I hope no one got caught on that. And great job, Alexa, right there. All the answers. You're getting it. The center line in a box plot signifies the median, and that is definitely true. As you can see, the median for each of these groups. If we hover over it, we can see it. So every one of these statements is true, where we see here Q1, the median, Q3, the max. That is the min. The max can be outliers. This one has the greatest range. Hint for Canvas or for Kahoots coming up. So that is the greatest range, and that's all correct right there. So yeah, that's some good stuff on box plots right there. Let's check out another one. So here we go on another thing right here. A student in an intro to statistics class calculates the upper fence in a box plot to be 15.2. Her maximum value is 17. So what is a fence? A fence is going to be the point at which things become outliers. So when you have a fence, it's an imaginary boundary, probably about here. And anything beyond it will be an outlier. Anything within it is not an outlier. The whisker only goes up to the maximum data point. There's no data up to this imaginary fence. You don't see the fences. Fences are calculated by 1.5 IQRs above Q3 and 1.5 IQRs below Q1. So these whiskers are not the fences. That's a common misconception. The whiskers are the highest points that are not outliers. And the highest point that is not an outlier could go up to the fence. It's probably closer to about there. 5, so 3, so it's close to 7-ish, 7 something, about there maybe. So the fence, which we do not see, is just a graphical thing to tell us where outliers begin. It is not actually a thing we see when we make box plots. So is this an outlier? Well, it's above where the fence would be. Like this point is outside of the fence, and thus anything above the fence is an outlier. That's what fences are. A student wants to determine whether or not she has an outlier. So what can we derive from Q1, Q3? I don't know if anyone's here, but from Q1, Q3, what can you derive? So Q1 and Q3 are representing the 25th and the 75th percentile of the data. So what can you calculate from Q1 and Q3? And let's go over here. We don't draw box plots, but this might help. So from Q1 to Q3, this distance right here is the interquartile range, because we're going from the 25th percentile to the 75th percentile. And so the interquartile range here is 6. So the box plot right now looks something like, if I go from 0 to, let's go to 15. And this would be 5, 10, 15. And so it's going to go down here for the bottom of the box and go up here. And we may even need to go further. So that is the box of the box plot. The median, this value right here, would be right here. Might not have gone to 4. It's close enough. Looks like. Where is the upper fence? So to find the upper fence right here, we need to go 1.5 IQRs above Q3. So I'm actually going to have to go a little bit off the scale. You could actually visually take this and literally go 1.5. And the half is going to be somewhere, I kind of drew it decently, somewhere about, technically visually there, but let's find it. So we're going above Q3, and we're going 1.5. I drew that 15 too high. There we go. Now it's visually accurate. So the upper fence just tells us where outliers begin, and outliers begin when you add on to here 1.5 IQRs above this. Now that's not the whisker. We're just going plus 1.5 IQRs. And so then you have to think, what is an IQR? Remember, we solved the IQR earlier. The IQR is going to be 6. And with the IQR going to be 6, 1.5 IQRs is equal to 9, because it's 1.5 times 6. So we're just going to take 1.5 times 6 equals to 9 over there. And that is 1.5 IQRs. So then we add it to Q3. So Q3 plus 9 is equal to 10 plus 9. And the upper fence right here, we did it visually accurate on our second try, is about at 19. Now, there might not be data there. The whisker might only go to this area, because there might only be data up to 14. If the whisker stops there, it's because there's no data. But if there was a point way up here, it would be because it's an outlier, something that's beyond the upper fence. So the whisker can go to the highest point that is not an outlier, but the whisker cannot go beyond the upper fence. It can go to the upper fence. That's the thing, too. It could literally go right to it. If a data point goes beyond it, it does become an outlier. If the whisker stops, it's because there's no data in this region. Like, this box plot would indicate to me that there were no observations in the region of about 12 to 19, or even here we can see there's no data. There's a large gap in the data from 12 to 19, or 12 to, what is that, 24, 25? So there's a large gap in the data after 12 to where we see an outlier high of 24. So very important. And this data set probably would look something like this, a little small tail. And this would be a very right-skewed data set because it's pulled out more towards the high side. Last note to have on this one is when you look at skew of box plots, you want to remember that the median shows you the 50th percentile, and there's a higher pull to the right side of the data right here, where 50% of the data would be above the median and 50% of the data would be below the median. So you can really see that it's kind of pulled out on that high side. Think of skew as like a pulling, like a Laffy Taffy or something. And you can see there's a high skew to the right side here, right to the high, left to the low, whatever way the tail goes. Good stuff right there on this question, understanding. And the answer is 19. Let's go put in that answer. 19, we got it. Let's just get it wrong. That'd be fun. So now let's look at another one right here. Okay, which of the following is not necessarily an outlier? Ooh. Well, I think I see the answer. So we have to remember that definitionally, can't say that word, by definition, a number which is more than 1.5 IQRs away from either end of the box plot, and we just showed that visually right here, it would work the same way on the lower side too. You could just take all of this and do a really horrible flip right there and calculate the lower fence. The lower fence is in the same, the same distance away, but distance away from Q1. So you could calculate the lower fence by doing 1.5 IQRs below Q1. The upper fence is 1.5 IQRs above Q3. So that one is true right here. An extreme value that doesn't belong to the rest of the data, well, it's kind of the definition of an outlier, is extreme values that don't make sense with the rest of the data. But the maximum value in a data set is just the highest point. This is the maximum here, and it is an outlier. That is the maximum for this group, and it is not an outlier. Some of these, like here, have an outlier as the maximum. Some of these do not. So not necessarily. So as it says right here, which is not necessarily an outlier. Sometimes the maximum is not an outlier right here. Sometimes it is an outlier right here. So definitely the maximum data set may or may not be an outlier. Make sure to include this in the range though. If you're doing the range, maximum is included when calculating range. We did the checkout earlier for the boys and girls problem. I think they changed the color of that once again. When comparing the box plots of two groups, which of the following should be done? Oh, great question right here for what we have. Ooh, good question for your write-up. Let's see. Let's compare some box plots. Should we compare the medians? Yes. It's quite clear to see. This one actually, ooh, the median's right there. It's very hard to see. Look at that. That's the median line, the box plot. Very hard to see. So yeah, it's very close to Q3. It's very compact. A lot of data in that region. And because you think from 50 to 75%, 25% of observations for the 30+ minute drive, maybe due to lack of data. 4. No. Something's weird about this. It's not what the box plot shows. Something's weird's going on. I need to talk to Jump about that. Let's add it. That's weird. There we go. That's a real data set. Jump, what are you doing? That's not right. So here we go. Here are the actual values of the median in Q3, and there's 25% of observations. Now, I think it said there's 30 data points. There's only 9 data points. So due to lack of data, we're probably looking at more unique points. Could you go over the spinal injuries? Yes. Is that the crowd crush one? Such happy topics here on such one. Hunter, you bet. Let me write that down here. We'll finish this problem, and then we will do these spinal injuries. So 43. And thank you, Hunter. 100 points for being here. I appreciate it. Stat 201, Chapter 4, quiz, spinal injuries. Let's go check that out here in a second. We could compare the medians, definitely. We could see if they're skewed. We were just talking about that a moment ago. We could see if there's outliers, those dots. We could compare the IQRs, and that is also being done in this graphic, comparing the IQRs right there. All those things can be compared, and you should definitely do those in your write-ups. Let's put a break in the video. Okay, did I already timestamp it? Why would I timestamp this? What am I doing? Here we go right here, jumping back into it. Let's do the spinal injury. Okay, we're finding it real quick right here. Should have pulled it up. Here we go. I think this is it. Is this the one? No, I think it's a different one. It's not the crowd injury one, right? Is it that crowd injury one? We haven't done it today, I know. I'm going to re-break in the video right here. Is it the crowd injury one, Hunter? I need chill music. Let's see. Here, we found it. Found it. Spinal injury. Okay, cool. Let me re-break the video. Not the crowd one. That's what I thought. I was like, that doesn't. So many injury ones. Oh, here we go. The spinal injury question. Let's do this. Okay, with this question right here, let's figure out what it's asking us first. First off, we are given a histogram, which is a univariate way to look at the data. Just what are people's strength? So if you're looking at just the univariate distribution, you'd see there's 2 observations here between 1 to 2. There's 6 observations here, 6 observations here, and 2 here. Very unimodal distribution. But you could also have them do different exercises with either their bicep or their deltoid. Where's your delts at? I don't know. But we know what biceps are. There we go. So we got the biceps and the deltoids, different ways that people are exercising. Now, interestingly enough, we don't see the median because the median must overlap either with Q1 or Q3. And remember, the box plots we've been talking about compare groups. So multiple box plots compare groups. So this is the same data, just split apart into 2 groups. Describe the shape of the distribution. Well, that's going to be the histogram right over here. It's very unimodal. Unimodal meaning one peak. And we have right here that it is symmetric. I mean, perfectly symmetric around that line. There are not outliers. And that's just the shape of the distribution right here. What is the range? Now, here's where you have to watch out. It looks like it could be 4 from 1 to 5, but that's not. The value is actually 4 right here, and that's from seen right here going from 1 to 4. This is where the mistake is often made. What is the range, Hunter? So, Hunter, what is the range? If the minimum value right here is 1 and the maximum value is 4, what would the range of this data be? If the minimum is 1 and the maximum is 4, what would the range? This is a very common mistake on this question, to look over here and say, 1 to 5. But this shows the actual data points going from 1 to 4. The range would be what? 100 points on the line right here. What would the range be? So the data actually goes 3, Hunter. You got it. Great work, Hunter. So that's the way to look at the range. Remember, the bins collect the data. It's actually that these points are at 4 are actually in this bin. The bin goes from 4 to 5. Technically, if a data point was 5, it would actually go in a bin from 5 to 6. The last number is actually not included in the bin. Histograms are not going to give you a really good idea of the range of the data. We showed something like this earlier. If we go to analyze distribution on this, the range of this data set right here is 14, and you might not get that if you look at the histogram. Take a look right here. It looks like it goes from 0 to like 17, but it goes from 1 to 15. It's just that the bins collect the data, and the bin widths can change the way the data looks. So don't look at histograms a lot, as I change the histogram crazily right here. Unless you have really tiny bins like that, maybe that would work. But the best way to look at the range is to see the lowest point and to see the highest point, and then you could find values at it if you have a scale. So you can see it goes from 1 to 15 right there on this box plot. And notice how the box plot's not changing. So you could have bins that look like this or like this, and you could think it goes from 0 to 20, but it doesn't. Look at this point right here. It's in this bin because it's like the lowest number in that bin. Very common error just looking at that and saying it's 4, but it's actually 3. Trying to trick you. And so good stuff right here on that. What fact about the results produces the two, what is hidden in the histogram, I should say? If you notice, there's differences among people's biceps and deltoids on how they reacted with strength after doing these exercises. So the strength is much higher for the biceps with more variation than the deltoids. Let's see. The differences in the averages, the variation in all the data is hidden in the histogram. Yeah, it says averages. Let me think. I'm a little worried on this one now. It's easy to describe, and it's hard to pick their answer. The variation in all of the data. Oh, no, it's saying the variation in all the data. No. The differences between the groups. Because the variation in all the data can be seen in the histogram. The variation between the groups, that's key right there. If it said the variation between the groups, then that might be a decent answer. But we have to do a comparison. That's hidden in the histogram. You can't compare with a histogram unless you do multiple histograms. Very clear answer now that I saw it. First one doesn't talk about comparing. Which method had the higher, better median? And so the median of the biceps procedure is not visible, so you can't see it. It overlaps on Q1 or Q3. Is higher, it has to be, than the median for the deltoids, which is about 2. So they're just doing an estimate right here of where the median would be at. Might be hard to see, but it's probably close to 2. It's actually very line up there, barely visible. And then the median for the other one has to be between 3, or not has to be between, it has to be either 3 or 4, because it overlaps one of those. Sometimes if your numbers in a box plot overlap, and I'll show you this, you could have a data set right here that looks like this. And your box plot is going to look like, you might say, no way, is this a box plot? Here is your box plot. Might be better if I do it vertically like we've been looking at. That's your box plot. Your box plot's a line. Hunter, why would the box plot be a line? And just think about this like, well, the box plot's a line because if you look at all the values I entered, every value is identical. Does that make sense? So that's the min, that's the Q1, that's the median, that's the Q3, that's the max. So sometimes you get things that overlap in position. So sometimes Q1 and Q3 might overlap with the median. So you might have, you can't really see it. So sometimes they do a better job of graphically displaying it by like making it a thicker bar. I think Jump actually does that. So here, I'll try one more data set. And let's go here and go like 1, 3, 3, 3, 3, 3, 3, 3, 4, 5, 6, 7, 7. Do some more 3s. That's good enough. Well, 3 should be the Q1 and the median, at least by my estimates right there. And so now we should see Jump does a little bit better of a job. Don't want that. Oh, no, Jump doesn't do it. Maybe it does it on the other thing, because now we can't see it. Yeah, because the median and the Q1 are on top of each other. Maybe it's when you do it with analyzed distribution. Oh, no, it doesn't do it there either. Ooh. You can't see it. The median and Q1 are on top of each other, and that's why you don't see the line on the box plot. Oh, R does it. R does better. Pretty sure. Last try right here. I just want to see if R does better. One more reason to use R. Oh, that doesn't do a new data sheet instead of R, apparently. Control-Shift-N. Data, concatenate vector. Wrong button. All right. You know what? Smaller data set. I've got a trick for it. There we go. And box plots. Data. What? Oh, too large. Yeah, sure. Yes, this is what I was talking about. I prefer graphical displays that do the following. Makes more sense to me if you're going to distinguish that your median is on the same spot as a Q1. Then this would display it right here. As opposed to if the median and Q1 are in different spots, then you could see a non-overlap with the data, and there you see it right there. So here's where they overlap, and here's where they don't, and some graphical software will make it clearer, but sometimes the median is on top of it in example 1, or it's not on top of it. So this is a clear example of where it has to be on either Q1 or Q3 and kind of hidden from us, and that's what they're talking about right there. Which method was the method with the higher median always better? No. Because we see here with the deltoids, there is a maximum here, which is higher than the minimum of the biceps. So the method with the higher median was not always better because the maximum of that method, because the minimum of that method is less than the maximum of the other method. So the minimum of this method, the one that was higher, is not always better because it is lower, because the minimum of that method is less than the maximum of the other. Here's the minimum of that, it's less than the maximum. Which method produced more consistent results? So it's going to talk about the IQR right here. The deltoids is more consistent. These are outliers. The range is very similar. So the deltoid has a more consistent, let's hear it here, but all but 2 of the data values. Yes. So those are outliers. And there's a similar range to both. Like this goes from 1 to 3. This goes from 2 to 4. So that's a range of 2. But these are outliers right here. I mean, they're both pretty variable, and it's a smaller data set. They're making some pretty unique assumptions right here. Hunter, did that help out? Did that make more sense for this question? We got time for at least a few more questions right here, but let me know what you're thinking. Hopefully that kind of walks through everything, and now the question makes a good bit more sense, and kind of understanding what box plots are, why we use them, and all this good stuff. I wonder if... You're welcome, Hunter. I'm going to try something right here. We need a little hacker man right here. Let's make this happen right here. Drop those questions in the chat if you have them. Hit hacker man twice. Library GG easy. Oh, no, it's library. Oh. Trying to make a better looking box plot. Let's make some good looking box plots here. Let's check this out. What are the arguments in GG box plot? We'll make a thing in the thing right here. Piping options. Maybe 474 will check this out. So if you have a question, drop it in the chat. Working with pipes. So this is a little bit on working with pipes right here. Let me do GG title. Oh. What? Oh, no. Oh, what am I doing? It's not a pipe. There we go. Let's see. No argument missing. Drop the questions in the chat if you haven't. Let me know. What does ggboxplot take? Data XY. What? Oh, it's the data. Well, wait. X equals dose. Oh, one says a word. What? Why? Look at the tooth growth data frame, see how it looks. Oh, we need to do a Y. We don't want an X. We analyze Y variables of interest in box plots. So easy to make errors. Easy to make errors. And then say, what have we done? We analyze Y variables of interest and break them apart by X variables so we can analyze people's heights. And oops, I just ran like everything on the screen. And then we could break apart the height right here by somebody's gender. And X equals gender right here. So then we've done that. Now we should be able to color code it. And so let's try to color code this right here. So let's go to the title and say gender by height. And there we go. We got a cool interactive graphic so far. So we've got this right here. Now there should be more options. I'm using the ggboxplot option to do all this. And there should be a few more options to then make this look even better. But we're just getting really nice graphics, just trying to. What's really great about this also is you can like zoom in on this. You go right here. We go to color. Yeah, let's go to cull. Does this have the cull argument? It does. Yes. Perfect. Yes, Abigail, assignment 3 right here. AT&T customers. Yeah, let's do that. And this is making like nice box. So Abigail, your thoughts on this graphic right here? I hope, I don't know, I think it looks pretty nice. But just kind of working with this right here, trying to make a decent looking side-by-side box plots using code inside of R right here. And these are interactive graphics that you can like adjust, create, hover over, and see. But a little bit of R code and we get everything. I wish it would stop telling me how to do it. You can take pictures of it. You could save it. But these are all interactive graphics showing you the values with the mean. Oh, it even says lower fence. Is that the value of lower? Yeah, same what the lower fence is at. So is that the lower fence? That's the whisker. Might need to talk to the person who coded that. But that's got it. Abigail, let's head back into this. Abigail, thank you for the question. Let's do it. Okay, we got some questions for assignment 3 for BAS 320. We start the coding, and then the coding starts. Abigail, I hope you're having a great day. Let me throw you 100 points right there. Let's do this. Assignment 3, AT&T customers. We'll be going over this today in class. Okay. So let's see right here. Assignment 3. BAS 320, assignment 3. AT&T expected customers. Let's go check this out. Here we go. So assignment 3 is going to be working with associations between categorical data and I think also some categorical quantitative. So we have the textbook right here. Make sure to use the textbook. A lot of questions right here. Which number question is it, Abigail? I think I'm trying to remember what the phone data is located in. So which one is it? Good to see you here, Alex. Which question is it? I could pull up the textbook right here. We go grab the textbook. Textbook. Aye. Is found under the modules. I'm making everyone yawn probably. And we need to go here to the homework packet. And the homework packet is going to have download homework packet. Open up the homework. Oh, just open it. So the AT&T customers. So many scatter plots. Where's AT&T customers? Is it AT&T? Is this for the quiz? On the quiz. Good question with the quiz. So that is the quiz. That's what I was thinking it was. So with this, let's try to do I think one of these asks expected right here. So let's take a look. So many questions where I have to go look them up. Let's see. This starts on page 70. And let's find a very similar one right here. Very similar problem. Very similar problem. Here we are on page 70. Oh, this is question number 2. And this is the one on page 70, is it? Okay, I like it. So this right here, question number 2 on page 70. Let's go to that. We're going to re-timestamp question 2. And this will hopefully answer your questions, Abigail. So check this out right here as we talk through this and we talk about how to solve it. And we see what we got. Here we go. Okay, so for this question right here, we want to take a look at and see how to solve certain values. First off, how many students are in the survey? In other words, what's the sample size? So let's just go through this, Abigail. We'll solve each thing right here, and this will answer your question, I promise. So how many students were in the survey when you look at this contingency table? That's the easy question. Like, free points. How many students are in this survey? I got that. If you're in 201, we're doing these same things, or we just got done doing mosaic plots and contingency tables. 579, exactly. That's exactly what we see right here for the total amount in the survey. How many males sit in the front row? Now, this is what we call a cell. A cell is a singular observation of a bivariate combination. So all of these are cells, like not those on the sides. These are cells. Those are cells. These are cells. It's like the inside, 89. I believe you're right. That's how many males sit on the front row. Awesome. Report the marginal distribution. Now, when you hear marginal distribution, we always say this, and you'll hear me say it. You'll hear Owen Wilson say this.
Wow.
Where is the marginal distribution located? Marginal distributions are located where? Always in the wheres. Marginal distributions are always located in the wheres. So it says report the marginal distribution of location. Give the numbers as percentages. So we need to go through and find each percentage right here. So the marginal distribution is located where? So just a quick way to remember, the marginal distribution is always in the where. It's always in the what of the table. So don't ever think it. Be like, oh, it's the marginal distribution. So it's the distribution that's in the where. The wheres of the table. I'll throw some more points. So if it's the marginal distribution, kind of, yeah, that's where the margins are. So Abigail, so it's the total right here. That's one marginal distribution. And that's the marginal distribution of location. Now, don't look at the inside of it. The marginal distribution right here is the distribution in the margins. Does that make sense? That's only looking at one variable. We were actually doing some of this earlier with Stat 201, but we practice and we learn these things to make sure we have it down very good in 320. So this is where I think people take a sigh of relief because we're doing a little less coding. But watch this. We could go over to R, and that's question 1. Here's question 2. We could code a vector of values. And I'm not saying this is the answer. Not answer. And say totals. And then go here to totals. Divide by sum totals. And if it wants us to report as percents, I could just take this whole thing and do what to it? If I want to turn these into percents. So I could take that vector and divide by the sum of the vector each value. If I want to turn it to percents, I could just take that whole thing right there and do what to it? So now I've got percentages. I just took a vector of information. Don't grab the total too, because that'd be the total. Like, you only want the positions. and then think about what it would be. Like, make sure it makes sense when you look at it. Like, be like, how should these numbers look? Because to be specific, you don't want to grab this number because it should be 107 divided by 579. And you could double check your math to be like, okay, that's the percent sitting in the back. That's the percent sitting in the front. So if we want to turn these to percentages, what do you think we should do to them, Abigail, right here? We're almost to the one that you're wondering about. If we want to do these as percentages, what do you think we should do to them? Like right now they're decimals. And if we want them as percentages, we should do what? Thoughts on that? Let's just manipulate these and change these to percentages from decimals. Be like, I don't like decimals. I like percentages better. So we could times by 100. And then, I don't know, good job, I'll go right there. Exactly 100 points. Well, watch this. I'm just going to call this X for the moment. And then I'm going to say here, round X to 2 digits. You know what you could do? Names of X. I can't remember the order. Brian can't remember order. I don't want to put something down people do. Don't do that. There you go. You could name your vector. Now we've created a named vector because we just called position 1, Brian can't remember order, position 1, 2, 3, 4, respectively. But is this making sense right here, Abigail, how we can take this information and display the marginal distribution by saving a vector, calculating the percentages into X, naming the positions of it, like position 1, 2, 3, 4, and then displaying it by rounding it to 2 digits. So really great way to just this is why we don't even have to worry about rounding with R. It's like, well, how round this to 2 digits? Okay, round. So I really love R for those reasons, because when I'm doing 201 stuff, I'm like, oh no, I'm going to round it wrong. But when I'm doing it in R, I'm like, oh, I just got to make sure I code it right. So if you code things the right way in R, you always get the right answer. And then you probably want to look at those and make sure they add up to 100%. So make sure everything's coded correctly. So we're right to, I think, the one you're wondering about here, where it says do the conditional. Oh, is it unexpected? Here we go. It's part E. It's almost there. We got this. Report the conditional distribution of location for females. Now, this is very similar, but this time in a conditional, we will only talk about females. So when we do the conditional location of females, the work is exactly the same. It says compare it to the marginal. So we are going to report this right here out of this amount, and then compare it to this to see if there's differences. This is what we're looking at with mosaic plots, which we were looking at earlier today. We had some mosaic plots. And when you look at a mosaic plot, the marginal distribution is the distribution in the margin, which is everybody. Here's the percent of people who've broken a bone for everybody. Then here's the percent of males who have broken a bone. Here's the percent of females who have broken a bone. And then you could compare less females who have broken a bone than the marginal, which is everybody, or you could compare males to females. We are going to compare the females to the total, which this is not the same data, but that's what these tables are doing for us. We are doing the exact same thing that Jump is doing right here. You might say, well, why don't we just use Jump, where you see the counts in the row percentages. It doesn't actually give you the marginal percentages right here, though. Marginal percent would be 228 divided by 432 and 204 divided by 432. So we would need to do the same exact calculations, but grab these numbers. Maybe. I don't do a lot of 471. I mean, you could ask. I don't have the assignments, and I can maybe allude, and I don't know. You can always ask. I can give you my advice, and my advice might be to go to Adam, I think. Either Adam, I'm trying to think who teaches 471. The advice might literally be go to Adams. And so the same calculations right here would be done as we did. Just ask in the chat publicly is probably the best way, since I always want to be open. I don't want to give too much help. Since the class I don't teach, I feel better about saying if you want to ask kind of, and I might say, oh, I always want to, does that make sense? I just want to be open about whatever help students get. So if someone's like, hey, wait, did you help this person for anyone? I'll be like, oh, well, it's there in the video. I can probably talk about stuff, but I don't know how specific I can go into, and I don't want to really solve something too much because every teacher has different guidelines for each class on different amount of work we could possibly give. So that is how we do the conditionals. We just need to run the numbers right here for females, whatever it is, and then we literally have the code written right here, which would solve. So whatever it would solve to, it'll solve to, and you could just use the same mathematics you're doing right here for this. Try coding it on your own, but once you have it written, you could do that right there. So you could Just input the vector. And with this right here, we get to the big question. Are you ready, Abigail? Here's how to solve it. So the question is, how do we get the expected counts? So this one says, calculate the expected count of females who sit in the middle if there is no association. And this is on the Canvas content. So females who sit in the middle, expected count. Here's the formula. And it's a little tougher on the Canvas content because there's not the totals. Be very careful in your mathematics. Be very careful in your addition. Here's how we do it. Expected counts are row total times column total over grand total equals expected. Anytime you're doing this, make sure to circle the one you're talking about. Females who sit in the middle. And that would point into right here. Now, that's not the answer. That is the observed count. That's called the observed count. That's how many we observe. We observe 426. We're solving for the expected. And then we need the grand total. So the grand total is this right here. Easter colors, maybe. That's the grand total. So we just need to solve this equation. Now, you will have to get the sums. You'll need the sums. Does that make, Abigail, does this make sense? The expected count of females who sit in the middle is we would expect, if there is no association right here, to do 232. Oh my gosh. 232 times 329 divided by 479. There we go. We expect 131. Yep. So make sure to do row total times column total over grand total. And that'll get you the expected. I did the wrong thing right there. And make sure. So there it is right there. Row total times column total over grand total. And then point in on the one you're talking about. You will probably have to add up all the values. But what's really good about this is if you have data inside of here, we don't have to solve these by hand oftentimes. We need to understand how they're done a little bit. But if I go here to the association between somebody's gender and their handedness of data survey 10, expected counts are solved for me. Now, it looks to me, I'm not going to look at it right away, the expecteds are going to be kind of close to the observed because there is very little differences right here. So if you notice right here, there really isn't difference in the conditional distributions compared to the marginal distribution. Here's for everybody, everybody's gender. Here's the right-handed people's gender, the hard-to-read category group gender. Ambidextrous and left-handed goes in that order. I guess, yeah, alphabetical makes sense. So ambidextrous, left and right-handed people are all pretty similar in distribution of gender. So probably the expecteds are close to what we observe because there's very little association right here, or next to none, high p-value. And so when you look at this, you would say the observed amount of females who are ambidextrous are 12, and we would have expected 12.7. Those are very close, which are going to lead to small discrepancies right here, which is the sum of the observed minus expected squared over expected. These are things we'll be covering in class. And you do get notes on the test. So it's not about knowing or memorizing all this, which I've memorized from doing for many years. It's about understanding when to apply it. And a discrepancy is basically how far those numbers are off from each other. So when you think about the discrepancies here, they're rather small. But if you go to the discrepancies we saw previously, this has much larger discrepancies and i.e. a smaller p-value. Still the same sort of calculation going on because this is the discrepancy right here is the Pearson chi-squared of 8.562. We don't really interpret it. We don't talk about degrees of freedom for the chi-squared. It does technically have 1 degree of freedom, but we don't have to worry about calculating the p-value. It's done for us, so we don't have to worry about talking about the chi-squared. Also, and I do want to mention this for our classes, we do our p-values by random permutations, which means every time I run this, I will actually get different estimated p-values due to the random permutations. It's a very advanced way of doing stuff. So really cool. Adam, did you put the question in the chat? So Adam, put the question in the chat if you have it. Let me know what you're thinking, Adam. We're going to end off here in just a minute or two, maybe. But Adam, what are you thinking? Drop it in the chat right there. Let's do this. Abigail, did that help? Did you get it right? Good question there, Abigail. A lot of great work when we talk about the quiz today in class. A lot of good practice. We have big chapters to cover. People should get excited because, let me send out the thing for class. Class in 25 minutes. We might end here in a moment. I think these only go to 4:30, but let's see. Last class of the day. Class half. What? Week half over after this. Today is not it. Google Calendar. Tomorrow is the business analytics event. Yeah. I wonder what time break is. Let's see. Oh, wow. That's late. Off the top of your head, do you know the equation to find the upper and lower control limits for a p-val, p-chart? Oh, you're talking about 340, right? It's probably like 3 sigma limits. So p-charts are imperfections, basically. It's something happens or does not happen. I believe so, right, Ben? But Google it. Google it. Google it. Or email Charlie Quick. I think Charlie Quick teaches that, right? Charlie's super great, super quick on emails too. You didn't have to count. It's probably like p times q over n square root times 3. Which is probably like the probability, like this is not the right answer. Like if I had to guess, this is a guess, do not take this as the answer. With my knowledge of statistics, I would think it'd be p times 1 minus p over n square root. I taught this class a while ago and I haven't just done it in a long time. And then times 3, because 3 standard deviations above or below the mean. So the upper and lower control limits are usually 3 sigma limits. So do not take my word. Definitely go and look it up. Email Charlie Quick. So huge thing right there, Ben. Email Charlie Quick and also look it up. Don't take my word for it because I haven't taught the class in forever. They'll be like, Brian says this. And be like, well, that's why we don't have Brian teach the class anymore. And they'll be like, yep, Brian, that's why we said, Brian, nope. That's why Brian doesn't teach that class anymore. I got wrong the 3 sigma limits, and they said, you're done. You're done. You get wrong the 3 sigma limits. You can't teach the class. Charlie is such a pro at that class. Of all the classes I've taught, I've always wanted to get better at some, and I hope to reach his... Like, he knows that stuff inside and out. He teaches to industry experts. Class in 20 minutes. See you soon. Click here. Charlie is an industry expert. And I took the class from him years ago, so I should know it. And yeah. Don't blame me. Oh, what's up, Caroline and Rose right there? 100 points to you both right there. Thank you so much. Did you see we made some cool graphics in the viewer? So thank you so much, Caroline and Rose right there. I appreciate that. Where did we make that graphic at? I'll show the graphic we made. So we were doing, you might have saw when we were working on the graphic right there, we were able to make a really nice little box plot. Look at that. Some of the power of R right here will end on the power of R. Yesterday was the power of love on Valentine's Day. That's an old song right there, the power of love. If you haven't heard it, it's from Back to the Future. Christopher Lloyd, Back to the Future, Michael J. Fox. Just going right here, doing gender by height, and we wrote a little bit of code earlier. So shout outs to Rose and Caroline right there. Awesome stuff. We got a big event tomorrow night. Our education, additional background content. Nice. Well, I appreciate it so much. Thank you. It's like, oh, look at that. All these hover abilities, all these great things. Can we do, isn't there another argument? Let's look at the arguments in ggplot real quick. What is the other arguments? Repel. Oh. GG theme. Okay. Theme oh, so we can call the GG theme on this. Oh, cool. So we can change the theme pretty quickly. It's a function to call the theme. Oh, maybe. Oh, yeah, we are. Look at this. You can choose between different themes very quickly on this. I think dark is really interesting. If you do that, it's gonna... It might not look that good, but we'll see it. So you can change the theme of these to many, many different themes. Void. It's not bad. But you can just be like, which of these works best? Transparent. Interesting. Whatever you want. Pub clean. That sounds good. I don't know. All your different options. You can just look through them all. There's even more packages with even more options. Cleveland. Why not Cleveland? Cleveland rocks. Yeah, Cleveland does kind of rock. And so let's go right here. Font label. Interesting. Adds param, color, size, shape for the argument adds. I haven't done that. Add character vector for adding another plot element, dot plot, or error bars. Allowed values are one of the combinations of none, dot plot. Okay, so sure, let's try a jitter on it. Is that the way it works? Add equals. Whoa! No, we don't want that. What have we done to it? Mean standard error. Standard error of the mean right there? No. It's not standard of the mean. Median hollow. I just can't tell. I just like seeing. I don't know about that. Median Q1, Q3. Oops, did the full thing. Let's run this again. Median Q1, Q3. No. Last one of the day. Median mean confidence interval? Oh, it's mad. It's mad. It's telling us it doesn't like it. It's saying, what are you doing? Warning attributes, something about it. It doesn't like it. It is giving the mean. I think it's just showing the mean. No, it's still mad. Well, let's remove the add on it. And now it's not mad. Now it's not mad. Well, we broke it, but that's the point. Just figure out, just see what it's doing, and just have fun with it. And yeah, with that, we'll be back here next time. Good night, everybody. Good day, everybody. It's 6 p.m. in Knoxville, studying, working hard. You got this. Rose, Caroline, Ben, awesome right there. Abigail, great work. Adam, great seeing you. I'll be back doing some 320 here in just a little bit. Bye for now, everyone. Bye. Almost time for 320.